And we kind of showed how when you solve an equation, what you're doing is figuring out what number makes that equation true. What I'm going over in these notes for a lot of you guys is probably going to be some review. Let's get logged in, baby. And that's okay. All right, that's why we're not spending a long time writing stuff down today. So you're going to see our big idea, and you don't need to write anything yet. I'll show you in a second. We're going to add a text box here. Okay, in a second, we're going to add a text box there if you want to go ahead and add it. So our big idea is that when we're solving an equation, you're figuring out what that variable is equal to, like what it takes to balance it out. When you were in middle school, a lot of teachers use the idea of a little balance beam, page 4, baby, in order to be able to show you that the equation, that the variable, like what it balances out with. So in this case, you've got an x kind of on one side of your balance beam. You've got 3 on the other side of that balance beam. So this is kind of a hands-on way of showing that x equals 3. It balances out, right? So in order to figure out how much a variable is worth, how much it weighs, it's got to be all by itself in that equation. If I want to figure out how much I weigh, sense for me to stand on the scale while I'm like holding my kid or my cat. Does it make sense to figure out just my weight? It doesn't, right? It would be stupid if I'm trying to figure out what my weight is equal to, how much I weigh. If I stand on that scale while I'm holding something else, that doesn't make any sense. So for that reason, when you're trying to figure out what that variable is worth, you got to have the variable all by itself. There is a big kid word for saying what that variable is worth. This is where we're going to add our text box right here. Everybody should be adding a text box right now. Everybody should be adding a text box right now. Alert. I'm barely making you write anything today, so I need you to hang with me here. So the big kid word for getting the variable by itself, you might have heard it. It's called isolating the variable.
We are here isolating. What's that mean?
What does it mean? Because honestly, I don't know. What does it mean? Like one-on-one? You're by yourself, right? I don't know about you, but during this pandemic, I felt pretty isolated. There's lots of places that, I'm serious, y'all. I don't know if I can't deal with sitting at home with just my kids. That's why these masks, please wear them right, because if you're eating or drinking, because y'all, you can't send me home to just be, back up a page, baby. You're just one page ahead. So isolating the variable is the big kid word for getting rid of that variable. We're going to look at some examples of how to do that in a minute, but right now I just want to give you the words. If the variable is not isolated, we've got to get rid of any number that is hanging out, that's chilling out over there with that variable. And in order to do that, we are going to use something called, everybody add a text box right here. Inverse operations. Yes, sir. Sorry, that was kind of messy. Okay, inverse is another word for opposites. You're going to see when we put it in action in a moment. That word operations is kind of ugly. Let me try to make it a little prettier. It's a really good thing I'm not a language arts teacher. If you guys actually had to read my words all the time, it would not be pretty. So inverse is another word for opposite. So kind of like that really that cheesy dance thing that they play at weddings, cha-cha slide, when he's like, reverse, reverse.
That's the best elementary school you can ever do.
So instead of reverse, reverse, we're inverse, inverse, okay? So our goal, getting the variable by itself, isolating that variable. How are we going to get that variable by itself? We're going to walk through an example in a moment. We're going to do it by using inverse operations. And the very last step when you're solving an equation, if you do an inverse operation to one side of the equal sign, you have to do it to the other side. I know, or otherwise, if you don't, your equation looks like that. It's jacked. If you do something to one side, but you don't do exactly the same to the other side, it's not going to be correct. I had a middle school math teacher who explained to me that math is the best subject in the world because math is fair. Out here in real life, frequently, we don't get treated equally, unfortunately. A lot of us don't get treated fairly. The great thing about math is fair. Everybody gets treated the same. If you do something to one side of the equal sign, you have to do exactly the same thing to the other side of the equal sign because mathematics is always fair. So that was kind of the middle school way of explaining it. What you do to one side, you have to do to the other. In high school, we call it something else. We call it a more big kid term. So add your last text box to this page right here. When you are performing the same operation on both sides, you are doing something called the properties of equality. And we're going to walk through an example of those in just a moment. So the big kid way of saying what you do to one side, man, that was ugly. What you do to one side, you have to do to the other side. The big kid way of saying it is properties of equality. If you see on a standardized test, your ACT, your SAT, something like that, and they say, what property of equality are you using? That's just the big kid word for what you do to one side, you got to do to the other. Now that we're in big kid math, we got to use big kid terms. So you're always going to hear me say that from now on. So our number one goal to isolate the variable. How are we going to do it? We're going to use inverse operations. And finally, what you do to one side, you have to do to the other. The big kid word for that is properties of equality. So now that we've got those three terms, let's see those terms in action. Let's actually solve an equation by scrolling over to page 5. So you guys know by now that I'm a big color coder. I really like to write things down and highlight and stuff. Because we're on Class Kick, you can do that if you want to, but it's not a necessity, okay? So if you want to do what I'm doing, great, in different colors, you can, but it's not required. Okay, so in example number 1, the first thing we have to figure out is we need to get that variable by itself. We need to isolate it. Right now, is that variable isolated right now? No. What is sitting over there with that variable? What's sitting there with the n? A -5, right? Now, this is what we've got to remember, and this is kind of what your classwork homework is all about. Whenever you have a number sitting next to a variable, what does that mean? Does that mean add, subtract, multiply, divide? What does that mean? When it's just sitting next to it. If we don't remember, that is okay. What does that mean? Multiplication. Good job. So that's what we're going to add in this first blank right here. This equation contains multiplication.
Y'all, can I ask a question?
I would love for you to ask a question.
You're telling me that I can look at this problem and assess it and say whatever n is, if I multiply it by -5, it should equal 30.
That is correct, and we're actually going to prove it in just a second too, sir. Yes.
Figure out what the problem's asking of me.
So what do we have? We've got multiplication. What is the inverse? What is the opposite of multiplication? Because this is like our thought process we got to go through. Division. Yes, sir. But thank you for raising your hand. I love that too. So the inverse is division. So we should all be writing the inverse. So what have we got in there? We got division, or I'm sorry, multiplication. How are we going to undo it? How are we going to get rid of it? We're going to do the opposite, which is division. And remember, now that we're big kids, we don't use that baby division symbol anymore. We are going to use a fraction bar, correct. So what is the opposite of multiplying by -5? It's division. If you want to use the little pen tool, or if you just want to add a text box, whatever you want to do to add this piece right here, I'll give you a second to figure that out. If you just want to use the pen tool at the top, or if you want to add a text box, either one is fine. If you want to use your keyboard, you can use that little front slash button and do it like that. Except that my screen's being slow. Hang on, you'll see what I tried to write up there in a second. So the inverse is division. But then we know if we do it to one side, we have to do it to the other side as well. So I'm going to add another division symbol over on the other side. And this is called the division property of equality. Again, that is just the big kid way of saying if I divide one side by -5, I've got to divide the other side by -5 as well. So you got to go through a little thought process here. What's in the equation? What's happening? Am I adding, subtracting, multiplying? What am I doing? What's the opposite? What is the inverse of whatever I have happening there? That's going to be division in this case. And what I do on one side, I have to do on the other side according to those properties of equality. I divided the right-hand side, so I'm going to need to divide the left-hand side. So let's see what happens. Oh, yes, sir. Hand side. Okay, so I was multiplying by -5, but I canceled out. I did the opposite. So those two -5s are going to cancel each other out. That's what happens with inverse operations. If you were multiplying by -5, but then we turned around and divided by -5, those 5s have now canceled each other out. So now I've got my n isolated, just like I needed it to be. So that n is isolated on the right-hand side. But of course, if we divided the right-hand side, we had to divide the left-hand side as well. Y'all are allowed to use calculators all day, every day on these. We do no calculators for the warm-up only. I don't want you missing equations questions because we're struggling with our number sense, okay? Warm-ups are for working on the number sense. Use a calculator because I want to know, do you know how to solve an equation versus your number operations? That's two different problems, okay? So 30 divided by -5 gives us -6. And then to Coach's point, you can actually go back and check your answer. And that's what I'm going to do now. There is literally no reason on the planet for you to have a wrong answer for an equation question, because you can go back and you can make sure that you did it correctly. So we're going to take, what did we get for our solution? We got -6, correct? Am I right about that? So I'm going to substitute into that problem -5 times -6. What's 5 times 6? 30. A negative times a negative is a positive. So does it balance out on both sides? It does. Yes, sir.
You draw that triangle up there at the top with the triangle and then put the positive, negative, negative.
You talking about right there?
Yeah.
Do I need to make it bigger?
It's upside down.
Oh.
The two negatives going on. But that applies.
Oh, so you do it. Oh, I see. Oh, gotcha. So it just looks like.
It applies to this.
No, triangle.
Oh, oops. You said the plus. Oh, I see what you're saying. So it goes like that.
There you go.
Just cover up what you got. So that's something negative and positive.
I know that was really ugly, kind of ugly there. All right, so any questions about number 1? So what operation do you have in there? What's going to cancel it out? Make sure you do it on both sides because math is fair. Is it okay? Anybody need me? I'm kind of looking. It looks like everybody's good to go. So that we can go ahead and go to number 2. All right, so for number 2, so we see, baby, we missed. Equation contains the operation. What's happening with this? We're adding a -2. That's what operation we have there. So we're adding We're adding a negative 2. What's happening there? You've got an n, you've got that variable, and then you added a negative 2 to it. So I got to identify what's happening with that variable. Then I need to identify, well, what's going to be the opposite of adding a negative 2? What's the opposite of negative 2? A positive 2. So that's one way you can do it. So what is the inverse? What is the opposite of adding a negative? We can add a positive 2. A negative 2 is going to be canceled out by its opposite, which is a positive 2. So what I do is I'm just going to stick it right underneath that negative 2. I know some teachers do it out to the side. I don't know, maybe it's just me, but that just always really kind of confused me when the problem went out to the side. I like to add everything like underneath. So we're going to add that positive 2 to the left-hand side.
Sorry, Laura, could I borrow a Chromebook for this period and bring it back?
Whose class are you taking it to?
Humanities, Miss Camacho.
Yeah, that's fine. From Miss Camacho? How'd she know to send you here?
Huh?
How'd she know to send you here?
Because I know Bernard has Chromebooks.
Oh.
I was going to take them for him and borrow the third.
Oh, yeah, he borrowed them from me. Yeah. You're welcome. All right. So we added positive 2. The inverse operation must be done to both sides. Math is fair. And we are doing that according to this time, it's the addition property of equality. Do we see a pattern here? They're all properties of equality. All that changes is whether we're adding, whether we're subtracting, multiplying, or dividing. So, and this is an important point too. That line is kind of like the middle of the equal sign. So make sure you add that 2 over on the opposite side. So you should be doing the same thing on either side of that little, it's kind of like your little wall. You got one side of the equation versus the other side of the equation. So we added a positive 2 to cancel out that negative 2.
That makes sense.
What part makes no sense?
Well, no, I'm just saying the people who invented math.
Oh. People didn't invent math. They discovered math because math exists in nature, boo. It's a thing.
Yeah, but it's adopted and that's property.
Fair enough. That's a fair point. So what's going to happen with this negative 2 and this positive 2? What's going to happen to those guys? They're going to cancel each other out. The whole point of adding 2 in the first place was to get rid of that 2. So those are going to cancel each other out. So now my n is isolated, just like I needed it to be. And then we had to do 14 plus 2, which means that we arrived at our final equation of n is equal to 16.
How many of y'all have seen this before?
Who tells me what operation's happening here?
So P is X, right? Well, P is 1.
Oh, wait, what?
P is -1.
Oh my gosh. Well, P's not -1, but that is better than I thought I was going to get. Okay, if you don't see a number in front of that variable, there's technically a 1 there. Coach says this expression where he says, you need a number? I got 1 for you. So this is really -13 is equal to -1 times P. So P's not -1, but there's like a little secret 1 there in front of that variable. So there's technically a -1 sitting there. So what operation is that when the -1 is sitting next to that variable? When you've got a number sitting next to something else, is that adding, subtracting, multiplying, or dividing? Uh-oh. What's it mean when the number is just sitting there? It means multiplication. There's technically a secret 1. You don't see it, but it's there in front of that P. So how are we going to cancel out multiplying by a -1? We're going to divide both sides by -1. Kevin, you made my day, brother. I really thought nobody was going to know that. I really did. Should have given y'all more credit.
Good job.
So we're going to divide both sides by -1. We know we're going to do both sides. Somebody fill in the blank for me. When you divide both sides by the same number, that is the what property of equality, do you think? Division property of equality. We're dividing both sides by the same number. You can tell we're being repetitive because I want that name to stick. So what do we already have? We're multiplying by a -1. If you don't see a number there, it means that there's a 1 there. So we got to cancel out that 1 by doing a -1. And we got to do it on both sides according to that division property of equality. So what's going to happen with those two 1s? Those two 1s are going to cancel each other out. So I now have my P isolated like I need it to be. -13 divided by -1 is a +13.
Good job, y'all.
Yeah. And that's it. That's all we're writing before we get to our classwork. I'm going to leave this open for the couple people that are still writing a second. You go ahead and open up that classwork if you haven't already. But I see some people are still writing, so I'm going to give you 1 second. Your homework assignment that's loaded on Google, while you're waiting for me to explain the classwork, I bet a lot of you could probably go ahead and open up that homework